For this video, we're going to revisit the triangle congruence theorems one more time, and this video is going to focus on how to determine which one to use if you're determining if two triangles are congruent, and also we're going to kind of add in what to do when you are given a triangle that isn't marked, if you are just given information on the side that tells you which pieces are congruent. So just a quick reminder, we've got all 5 of our theorems listed out here. We've got side, 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 angle, side, angle, angle, side, or side, angle, angle, whichever way you want to write it, angle, side, angle, and hypotenuse leg. Remember that hypotenuse leg is the exception to the side, side, angle theorem and can be used in right triangles only. So we're going to go through a couple of examples of problems and talk about what we know and figure out which theorem proves congruence. So here we have 2 triangles. I'm telling you that they are congruent, and we got to figure out what theorem proves that they are congruent. So let's talk about what we know. The first thing that we might notice is that these are right triangles, and we're given some marked information. So we know that AC is congruent to AD based on our tick marks here. We also have a shared side, so we know that AB of one triangle is congruent to AB of the other triangle. So I'm just going to mark that with a line. And then we have our 2 right angles, and we want to make sure that we can separate which angle we're talking about, the one on the right or the one on the left. So we're going to name those angles based on 3 letters. The end of the angle, to the middle of the angle, to the other end of the angle. So we would call the angle on the right angle ABD. Notice that the B is in the middle. That is the vertex of the angle that we're looking at. Then we're going to do the other side, ABC. So it's congruent to angle ABC. Alright, so now based on what we have, we can determine if the 2 triangles are congruent and what theorem. So I'm looking at my order, and the first thing I see is I've got side, side, angle. So I'm kind of giving you a jumping there. And then on the other side, it's side, side, angle. Alright, well, you know that we can't use that because we can't cuss to prove congruence. But we're looking at a right triangle. So if you get this result in a right triangle, that means that we know the hypotenuse and the leg. So the 2 triangles are congruent based on the hypotenuse leg theorem. So that's how we go from beginning to end to make our choice. So let's do it again on another set of triangles. And this actually looks exactly like the previous problem, except we are given different pieces of information. We still know that our angles are congruent. We still know that angle ABC is congruent to angle ABD. We still know that we have a shared side here, so AB is still congruent to AB. But this time, we are given another pair of sides that are congruent. We now know that CB is congruent to BD. So now we need to check our order and make sure it's the same in both triangles. So I'm going to start here, and I'm going to say side, angle, side. And on the other one, I'm going to go side, angle, side. Now notice I did not jump more than one angle or one side. In this case, I didn't jump either. But you remember, you got to be careful that you don't try to name them out of order. For example, you could not name this SSA because you would be jumping sides and angles. So right now, we've got side, angle, side for both of them. So the triangles are congruent based on the side, angle, side theorem. Alright, now we're going to get a little bit different, and instead of the triangles being marked for you, you're given the information over here on the right side. We are given that angle EDF is congruent to angle GDF. So if I follow those and look at the vertex, D and D, I know that angle EDF, that's this one, is congruent to angle GDF, that's this one. So I know this angle is congruent to this one. Now the other one I'm given is angle DEF, that's this angle, is congruent to angle DGF. So again, we can kind of use a shortcut here and look at that middle letter, that's our vertex. So we know this angle is congruent to this angle. And then we also have another piece of information from the picture, which is the shared side. So we can add that here, DF is congruent to DF. Now that we've marked it, we can check what our order is. So I know I can't go that way. So I'm going to start here and go angle, angle, side, angle, angle, side. So the two triangles are congruent based on the angle, angle, side theorem. And we got another one here, and it says, are the triangles congruent? They didn't give us any information, so we go just based on the picture. I know we've got a shared side here, so let's mark that. I'm going to start there because I can go to the right without jumping anything. So I've got side, angle, side. So here I've got side, angle, side. And now let's look at the other one. And let's start with the same thing. Side, angle, but I can't keep going because I would have to jump too much. That tells me that I got a problem and that the two triangles don't match. I can go angle, angle, side, side, but that doesn't match. Those two don't match. So can we prove that the triangles are congruent? No. Alright? So paying attention to that order matters. They will throw questions like this at you just to trick you. Alright, one more and then we're done. This is the information we're given. Angle NML is congruent to angle RQP. So as a shortcut, I know the M and the Q are the vertexes, so angle M is congruent to angle Q. I know that side ML is congruent to side QP. That's supposed to be a Q. And then I know that angle NLM is congruent to angle RPQ, so that's angle L and angle P. So I'm going to mark those. Are the triangles congruent? So let's check our order. In this case, we've got angle, side, angle. And does it match down here? Angle, side, angle. And that's correct. So the triangles are congruent by angle, side, angle. So for the questions, you've got 5 sets of triangles that you're going to determine if the two triangles are congruent, and then if yes, you choose the theorem. If no, you put not enough information because you can't determine that they're congruent.